I see students who tell me that trigonometry is difficult. It is not. That sometimes you just have to know one thing. If you know one thing, and when they start switching it around, just show them that you still know it. Okay, we have been doing 6 trig ratios since last week. Well, but guess what? Somebody is asking you to find the 6 trig ratios of the angle in standard position 240. The first thing you need to know is that this angle 240 is in the, first of all, let's count. First quadrant, second quadrant, third quadrant. 240 is right here. So this angle is in the third quadrant. That's where the angle is. And if you're drawing a triangle, that's where your triangle is. All right. And in the third quadrant, we already know that in the third quadrant, we have negative, sine is negative, cosine is negative. Only tangent is positive in the third quadrant. Because if sine is negative, cosine is negative, then tangent of a negative over a negative will be positive. So tangent of sine over cosine is going to be positive because sine is negative, cosine is negative. All right. Okay, so we expect tangent to be positive. This is what I do. I was in school like you before. So I would just say, I will put plus here at the beginning. So you will not forget. Trust me, people forget. People make mistakes. I also put positive here before even I start, because I know there will be positive. And then make sure I put negative here. All the ones that should be negative from even before I calculate. Then the next thing I ask myself, what is the reference angle? What is the reference angle representing 240? So remember the reference angle in the third quadrant, reference angle, let me call it beta. That reference angle is equal to theta, the angle in standard position, minus 180. So theta is 240. 240 minus 180 is 60. Therefore, the reference angle here is 60 degrees. 60 degrees. Okay. And since you already know that the reference angle is 60 degrees, what you need is a special right triangle, 30, 60, 90. So get you a special right triangle, 30, 60, 90. If this is 60, this is root 3. Root 3 is always opposite the... Root 3 is always opposite, I'm sorry, the 60 degrees. The side 30 degrees is 1, hypotenuse is 2. That is that special right triangle, which you must know. Nobody gives you, you will never see it in any formula sheet. That is the test is about special right triangle. Nobody gives it to you in formula sheet. It's not going to be there. And if it's, even if it is there and you did not learn it, you might still not know how to do it. So, but you're not going to see it in my formula sheet. Special right triangle 45, 45 will not be in my formula sheet. Okay. Okay, so now that, first of all, I know how to find the angle is in the third quadrant. The second thing, I know the reference angle, and the reference angle is 60 degrees. So I have to do 30, 60, 90. Okay, so now that I have done that, I can just draw and bring a triangle out. I can bring a triangle out and start now. Okay, so what is the sine of 60? I already put the signs where they should be. Okay, so sine of 60 degrees is opposite over hypotenuse. This is given to me. And if sine of 60 degrees is opposite over hypotenuse, and it's the third quadrant, it is negative. So I'll go to cosecant right here and go here and put negative 2 over root 3. Because it is negative 2 over root 3, I have to rewrite it 2 root 3 over 3. 2 root 3 over 3. Remember, minus is there, negative is there. 2 root 3 over 3. Okay? All right, so then cosine is given to me, so no problem. Cosecant is negative 2. Tangent of 60 degrees is opposite over adjacent. So it is root 3. It better not be negative because it's third quadrant. So what I'm trying to show you is that you know how to do 60 trig ratios when there's a triangle. This time they give you a table. And then the other time they will give you something else. Just to make sure, sometimes they will give you a unit circle. So that way they want to do it in so many different ways to see if you still understand it, but you do. If tangent is root 3, cotangent is 1 over root 3. And rationalize it, you have root 3 over 3. I better not see anybody fail this question. All right, so you see, if something happens here, I'm going to let you do 225. I'm not going to do 225 for you. But one thing I want to let you know is 225 is in the third quadrant also. And the reference angle for 225 is the angle in the standard position, 225 minus 180, and that is 45 degrees. So you're talking about reference angle 45 degrees. You draw yourself a 45, 45, 45, 45, 90. And remember we said it's 1, 1, root 2, and so on. So the rest is history for you. So it's if it is say 225 degrees, then 225 minus 180 is the reference angle, which is 45. So you are now dealing with 45 degrees right here. And we see that sine 45 degrees is root 2 over 2. Cosine of 45 degrees is root 2 over 2. Tangent of 45 degrees is 1, but it's in the third quadrant, so tangent is positive. This must be negative. This must be negative. Cotangent is also 1. Secant is negative. All right, and then you don't have anything to really, it's going to be an easy test. And you have to believe me and work towards believing me. All right, we find the exact value of cos 45 degrees. We just talked about that. Find the cosine of 45 degrees. Find the exact value. Exact value means that should be no decimal. Leave your answer in terms of pi. So these are all simple questions. If it is in radian, okay, that's no problem. Find the exact value of sine pi over 3, which is sine 60. Sine 60 is root 2 over 3. Let's see. You have to, by the way, root 3 over 2. By the way, even if you don't want to memorize it. In fact, if you don't remember that pi over 3 is 60, no problem. What you want to do is convert pi over 3. Multiply pi over 3 with, convert this to degree. Converting it to degree, you just put 180 over, you are changing it to degree. And then you cancel, divide by, remember that the multiplier is 180 over pi. If you're converting from radian to degree, divide by the multiplier 180 over pi. So 3 divided 180 is 60. Now you know, I want you to know that you don't want to memorize anything. Don't think, okay, pi over 3 is 30. Okay, why don't you multiply it out? Okay, if you don't remember, don't guess it. Okay, so now it's talking about sine 60 degrees and asking you for the special. Suppose you don't remember special right triangle, you draw it on your paper. And then this is root 3, this is 60, it's a special right triangle, this is 30, this is 1, this is 2. So, sine 60 is root 3 over 2. Everybody, people make mistakes, but you can avoid some mistakes, okay? Cosecant of pi over 4. Well, listen. First of all, you want to know what that angle is. Pi over 4 is 45 degrees. Cosecant of 45 degrees, you want to know what is the sine of 45 degrees first? Because if you forget it and make a mistake and put in something else there, so convert it to degrees, 45 degrees. If you don't remember, you multiply with the multiplier 180 over pi. Then the next thing is, okay, what is the angle? 45 degrees. Okay, then you're going to use 45, 45, 90 special right triangle. And the sine of 45 degrees is 1 over root 2 or root 2 over 2. But if sine is 1 over root 2, therefore cosecant is root 2, the reciprocal, and so on. All right, so I already talked about cofunctions. If okay, so this is cosine of 90 degrees, and if cosine of 19 degrees is the angle I'm talking about, I want to find the angle they are saying is 90 minus 19. So it is sine. So the sine of 90 minus 19, and that's going to be about 71 degrees. Same thing here, rewrite sine 33 in terms of cofunction, a big deal. There are things you have to do by yourself. All right. So I think I'm done with the review. I touched everything, trust me. I touched everything that I need to touch. And I'm going to let you make sure you walk through. Remember that if you're told to find the area of a sector or arc length, you be careful and make sure that arc length is not, you're not using degree. Okay, one thing I took out from there is linear speed and angular speed. I just write the formula, but it's not, I put it in unit 2 test. That way you have some few things to worry about. But for some reason, I don't know why students don't like linear speed and angular speed. Well, angular speed is called omega. I'm going to say it, but we're not doing it this time. It's omega is theta over time over t. And theta must be in radian, theta in radian. So I'm supposed to give you an application question on linear speed and angular speed, but I moved that to unit 2. That way, you just have a few things to worry about in unit 1. You need to make a good grade in unit 1. It's a morale booster. It's a morale booster when you do well in the first. Okay, and then the linear speed. The linear speed, whenever you're asked about linear speed, it's just like the velocity. Velocity, okay? And let me just say what it means, but I don't, it's not in the test. It's going to be in test number 2. But I want to say, because it's in unit 1, I want to say what it is. Suppose I have an arc length. Let me just tell you about the arc length. I have this arc length from A to B. And there is a particle moving from this A to B. And this particle swept the arc length of, let's say that the arc length is, let's say it's pi over 3. I can just say it's arc length, even though it's distance, but it's a distance in a curve. So it's an arc length. But the angular speed concerns the central angle. So any question on angular speed, you have theta over t, is talking about when that particle was moving from A to B in arc length, what is the degree measure it is sweeping? What is the degree measure in counterclockwise direction? So omega is talking about the angle in the center, central angle. The arc length is talking about a part of the second. Length is length, but it's not the linear length. Okay, so linear speed. By the way, let me write the formula, but we're not going to see it in this test. Okay, so velocity, which is the linear speed, is going to be the length of arc multiplied by, you can go to divide it by length of arc divided by time in seconds, because remember it's velocity. Okay, and I want you to know that length of arc is r theta already, r theta divided by, so this is the formula for linear speed. Linear speed is arc length over t. And then, by the way, you can be told, you can see that formula for arc length is velocity, or you rewrite it this way. Notice that theta over t is omega. Omega is actually a Greek word. I know you know the capital letter omega. If you don't know, that's fine. This is the capital letter omega. The small letter omega is the one I'm writing now. The omega is like W. So linear speed is omega mod. See, this is omega right here. This is omega. All right, multiplied by R. Linear speed is omega multiplied by R. So I want to take this question out because I've seen that every semester, some people skip the question. It's not difficult. It just maybe sounds difficult. The linear speed and angular speed. I already explained what angular speed is. The angular speed is omega, small letter omega. It is related to central angle. The central angle that a moving object covered. The linear speed is the part of the sector arc length. That is the linear speed. That the moving object, the object is moving. That's why it's called speed. And linear speed is the same thing as see, you will just write it at velocity. Okay, linear speed is velocity, and velocity is, well, you can say omega multiplied by radius. But by the way, because I have found out it's an issue, it's not for some sections, some more sections, they're afraid of linear speed and angular speed. But by the time we get to Unit 2, we do a problem, you'll be ready to do it on the test day. Okay, for now, I think I'm done. I have reviewed all the important things. The other things are easy. I know you're going to knock it out, knock the test out.